Hey doc, I think I've got an ear infection. Antibiotics are a wonderful medicine when dealing with bacterial infections, but unfortunately they're sometimes misused.
My car is making this funny sound. Chooka 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 chooka.
When antibiotics are misused, it can lead to them suddenly not working anymore. And if you ask folks like Richard Dawkins and Bill Nye the Science Guy, the answer is that this is incontrovertible proof of evolution right before our very eyes. It's an evolutionary arms race, they say. As our weapons of medical warfare get stronger and more sophisticated, so too the bugs we're fighting are getting stronger. They're evolving better defenses, making them immune to the best we can throw at them. The power of natural selection and random mutation laughs at our incompetent medical prowess. Bacterial evolution and antibiotic resistance is one of the all-time greatest hits regarding evidence for evolution. And it's true that antibiotics do sometimes stop working. And antibiotic resistance is a form of evolution, narrowly speaking. But is this a demonstration of the creative power of Darwinian evolution, or is there something else going on? Let's take a look more closely. Let's get to know these bacteria killers we affectionately call antibiotics. How do they keep us alive? Where do they come from? What's their favorite kind of ice cream? There's a lot of ways for antibiotics to defeat bacteria. Some explode it. Some gum up the works. Some starve the little bugs out. Others prevent them from multiplying, and so on. But there's essentially only one or two ways that bacteria can become resistant to antibiotics. The first and most common way bacteria gain resistance is that it's always been there. Antibiotic-resistant bacteria actually pre-exist the invention of modern antibiotics. There's an interesting story of some Arctic explorers from back in the 1800s. Turns out they froze to death before the discovery and use of antibiotics. Some morbid scientists found them recently and took samples of their gut bacteria and found that they already had resistance to some of our most powerful modern antibiotics. Just like some people are naturally short and immune to limbo bars, some bacteria naturally have a pre-existing resistance to antibiotics. Not because they've gained this ability after an encounter with the antibiotic, but it's just always been the case. That said, bacteria do have a neat special ability that short people don't have. They love to share. Not just cooking recipes and financial advice, but super personal things like their very own DNA. They'll swap loops of DNA called plasmids in a process called horizontal gene transfer, or HGT. Like third graders with Pokemon cards, they have no idea how they got them or even what they do, but they'll trade them back and forth, and occasionally, they'll share these resistance genes. Nothing new has been made or evolved though. Bacteria already had the ability to trade plasmids, and the genes for resistance already existed before antibiotics. This is hardly an arms race, and it's not a demonstration of Darwinian creative power, since there's no new mutations and no new genes that have been made. Not only that, but these extra resistance genes are frequently a net negative on fitness. Bacteria with extra useless genes tend to be less fit than regular old vanilla bugs. Imagine you're in a foot race. You usually don't need a duffel bag filled with camping supplies, a pickaxe, spare bowling balls, and a weed whacker during your typical foot race. If you do, great. Otherwise, it's a huge waste of energy lugging all of that stuff around, and it makes you less competitive. Bacteria with extra genetic load tend to be less fit than regular old vanilla bugs.
What about mutations though?
This is the second less common, but more interesting way that bacteria develop resistance to antibiotics. How does it work? Scientists are aware of pre-existing resistance. So to exclude it as a possibility in experiments, they can start with a single normal, non-resistant bacteria and let that multiply over and over again, and eventually the bacteria population can still develop resistance on its own. Here's how. When copying their DNA, organisms are pretty accurate and mutations are relatively rare, but given enough time, errors do sneak in, like typos or autocorrect when you're texting someone. Sometimes they're no big deal and you can get along in spite of them. But sometimes these mutations really do something and can confer resistance or even immunity to antibiotics. Amazing, that must demonstrate the mighty power of evolution. Well, hold your horses. It's sort of like someone who has no arms saying that they're immune to handcuffs. No legs? You're immune to toenail fungus. No teeth? Congratulations, you're immune to cavities. Think of how much you'll save on toothpaste and floss expenses. Deaf and blind? You're immune to getting annoying songs stuck in your head. Wow. This poor soul might technically be immune to those things in a perverse way, but it comes at a cost. He's hardly a more fit organism, and these mutated bacteria are just hobbled, busted up versions of the original. Darwinian evolution can't get very far by breaking things. Eventually, it'll run out of things to break. And in reality, when antibiotics are removed from the environment, these superbugs just sort of die out, because without the help of the antibiotics keeping the stronger, normal bacteria at bay, they can't compete and they die out. Those are the two ways that bacteria can resist antibiotics. Okay, forget about antibiotics. Let's look at the experiment that Darwinists always point to show evolution right before our very eyes. The granddaddy of bacterial lab work, Richard Lenski's long-term evolution experiment. In this famous experiment, Lenski has simulated in the lab, over the course of a few decades, more than 1 million years of evolution with bacteria. Since humans and other large organisms can take years or even decades to reproduce, it's difficult to see any change between generations happening in our lifetimes. But smaller microorganisms like the bacteria E. coli can reproduce in just minutes, letting us observe tens of thousands of generations and the changes that go along with that in real time. This is what Lenski has done for the past quarter of a century or so. Just let a bunch of E. coli bacteria reproduce and watched what happened. Pretty soon after the experiment began, he noticed that they started to grow much faster than normal. Then, a while later, Lenski's E. coli suddenly gained a new ability to eat something new called citrate. This was an earth-shattering find in the world of evolutionary biology. Scientists were swooning in the streets. To hear them tell the story, this was a huge new evolutionary leap, proving beyond a shadow of a doubt the power of random mutation and natural selection. But would you believe it if I told you there was a problem with this explanation as evidence for the creative power of evolution? No? Good, because that would be untrue. There are at least 3 problems with this explanation. What exactly happened to cause the E. coli to grow so much faster? Well, they broke their flagella. What is that, and why would it make them grow faster? The flagella is a little outboard motor of the bacteria. It helps them move around and do their thing. But Lenski's bugs were in flasks that were swished around constantly, allowing them to get nutrients without ever having to move. They were spoon-fed lazy bums. This usually vital part was not currently needed, so it was a waste of energy, and they got rid of it. It's like selling the wheels off your car when you're at a stoplight. You'll save a lot of gas that way, sure, but you haven't really made a better car, and it'll sort of be a problem the next time you need to go anywhere. Well, what about the citrate thing? It's gotta be obviously true that being able to eat a brand new substance is a good thing for these little fellas. Like if we could eat dirt or something. Imagine the possibilities. Well, to make a long story short, all of the complex genetic pathways and proteins needed to transport and metabolize citrate were there all along. Not only that, but E. coli also already had a sophisticated mechanism to turn this ability on and off depending on its environment, so that they could prioritize their optimum food source, glucose, and not waste energy. All that happened was that the sophisticated control mechanism, the switch, broke. This bacteria lost the ability to turn off an ability that they already had. Now it was stuck always on, wasting energy to try and transport and metabolize citrate even when it wasn't necessary. It's sort of like this alarm clock. It has the ability to make this lovely noise. It's a nice ability, but it can be turned on and off. But what if the alarm clock was broken so that it made that noise forever and could never be turned off? Much better, right? Right? How can this not be a win? Sometimes it's good for your alarm clock to make noise, but it's very good to be able to turn it off too. E. coli could already do a thing, and they were broken so that they did that thing constantly, whether they needed it or not. Maybe you call that evolution, but Darwinian evolution demands innumerable new genes, new proteins, new body plans, new organs, and complex characters that we see in nature. This is not that. It's equivocation. Using language so ambiguously that it misleads. For example, Aristotle was Greek. Greek is a delicious kind of food. Aristotle must have been delicious. Evolution has so many definitions that it's sometimes difficult to pin down what is meant by it. One could mean a shift in pre-existing populations, like Darwin's finches or peppered moths. or breeding or cultivation like dogs or plants. But these are miles apart from extrapolating random mutation and natural selection can build new organs or body plans, or universal common ancestry, zucchini are related to tuna fish, which is even further apart from the wild claim that it all happens strictly through materialistic processes. Darwinists equivocate when evidence is presented to prove one definition of evolution, where there is evidence and everybody agrees, and then another definition is quietly swapped in based on wild extrapolations to hoodwink people who aren't paying close enough attention. To extrapolate from antibiotic resistance to the larger kinds of changes evolution would need to make new animals is kind of like saying, last week, this cow could jump 1 foot high. This week, she can jump 2 feet high. Doubling at that rate in just 30 more weeks, she'll be able to jump clear over the moon. It's a bad extrapolation. There's a hard limit to how high cows can jump. And there's a hard limit to the time and populations available to evolution, and to the number of features bacteria can break before running out of things to break. Darwin didn't write a book called How Pre-Existing Organisms Break Themselves. He purported to explain how novel species came about from a single common ancestor. And at least as far as this is concerned, it was a failure. Darwin can't get very far by squandering pre-existing genetic information. Darwin's mechanism creates variation largely by throwing genetic information overboard and selecting for damaged or broken genes, blissfully unaware that it's marooning itself on an island of genetic fragility, making organisms, ironically, less able to adapt in the future, thus hindering larger scale changes from accumulating. There's an old joke that perfectly summarizes what's going on. Wow, you're so rich. What's your secret to becoming a millionaire? Oh, it's easy. First start with $1 billion and then light a bunch of it on fire. Bacterial evolution is lauded as a premier example of Darwinism in action, as Dawkins puts it, before our very eyes. And actually, it is. It doesn't demonstrate Darwinism's creative power though. Instead, it's a perfect demonstration of Darwinism's impotence. Make sure you're subscribed and ring the bell so you're notified when the next videos are released. Thanks for watching.